Good morning to all of you. Before we start today's session, please feel free to do event check-in. This will give you access to additional resources and information about events that we are running on Reactor, which are around similar topics to today's session. Also, you will be able to access Microsoft Consultant hiring link from today's session, which I will share. I will share the event check-in link with the event ID in the Q&A section shortly. We have launched our LinkedIn Reactor group. So please feel free to join the group to get the latest update on session happening on Reactor. I will share the joining link soon. Thank you all once again for joining us today. My name is Rashmita and I'm the event planner for Microsoft Reactor Bengaluru, India. The session will run over the next 120 minutes, including Q&A. The session is being recorded and will be uploaded to our Reactor YouTube channel within 3 to 4 days. I will share the link to our YouTube channel in the chat section soon. Quick word on our code of conduct. We display this at all Microsoft Reactor events that we run, and it's just a reminder to be aware of others. Key thing to take out here is to be respectful of other people's views, understanding of differences, being kind and considerate in the way you engage. The chat will be open throughout, and we do encourage you all to participate. Also, please keep your mics muted during the session. I would now like to welcome Mamta, our speaker for today's session. She is an enterprise architect and an author with 17 plus years of IT experience, skilled cloud solution architect with 9 plus years of hands-on experience migrating, automating, and optimizing mission critical deployments in various cloud platforms. Currently, she is working in TechScalable as co-founder, but for now, I will hand over to her to begin the session. Over to you, Mamta.
Thanks, Rashmita. Thank you. So I'll go ahead and share my screen. So hopefully my screen is visible and I'm on.
Yes.
Thank you so much. So hey, hi, good morning, everyone. Thanks for joining on a weekend during the puja days as well. It's good that people are dedicated towards learning new stuffs. So it's really good to see you people. So we would uh, start our session. Let's discuss what we would be looking into today. So our topic is to Dockerize an application. So here it was mentioned as Java application. So we would pick Java and .NET both because most of the time uh, some commands are different for different applications than people think it's just meant for Java. So our intention is we would have an application. It can be a .NET app or a Java app. And most importantly, it is a web application. An application can run in a VM. An application can run in a container, dependent on how you have designed it and how you want to deploy it. So this is a way of packaging our application. I would package my application as a VM image, or I would package my application as a container image. Today we are doing this particular portion. So we would have an app and we would create a Docker image out of it. Then we can deploy this in multiple various ways using different services of Azure. Like we can deploy it in Web App. Web App has two backgrounds. Web App VM is there, Web App containers are there. Because we have chosen container image, we would deploy in Web App containers. Or you can deploy it in Azure Container Instance. This is also a service of Azure in which you can run container instance or a group of containers as well. And then we have another service called as Azure Kubernetes Service. So multiple places you can go ahead and deploy it. So this is a way of deploying your application. This container image has to be saved in a place from where we would be picking up and deploying it. So this part, the part where you're building, the packaging part of it, it is actually building up of the image So I would say build. So this build would be two types of build. One, we would do code build, and we would do the package build. We would be building up the package. So I'll say build package. Two different things you are actually going to build here. You would build the code, produce the executable, like in .NET, we produce the DLLs, in Java, we produce the jar or the var file that you would be producing. And you would go ahead and then package that as a Docker image. So build the image, I would say. It could be a VM image or it could be a container image. In both the cases, you got to build the code. So we have CI pipeline here and CD pipeline here. First, we would see how we actually build it. We would learn the ways of building, what exactly are the steps with which we would be building the container image. And then we would move on in understanding how we can automate it. So this would come as part of Azure DevOps pipeline. We would automate the build and we would go ahead and deploy into our web app. So our focus today are on the boxes, which I'm highlighting. So this would be the path we would be taking up. We would have application, which we would containerize. So when we say Dockerize or containerize, we would be picking up tools here. We would use a script type of thing called as Docker file. This helps us in automating container image creation. So it does the image creation process automate. Then we would go ahead and use Docker Compose. We would see this tool as well. This tool is useful when we want to deploy a multi-container app. We want to deploy and test it, then we can use the Compose as well. So I'll put a little bit focus on Compose as well. We will see these two components in depth because our intention is to Dockerize. So we need to know how to write a Docker file so that we can containerize our application. So let's start with the session. So I'll be starting with Docker basics. I'll just save this so that we can come back to this in case we need something. So when we say we want to containerize or Dockerize our, if you see the topic was mentioned as Dockerize or containerize an application, either or. Sorry, there's a typo. Containerize the application. So you have an app, you have all your source code here, residing here. I can manually do a Maven build and then produce a executable, like this produces a war file or a jar file. This output, I can normally we take and we go ahead and deploy in a virtual machine. So this, which is produced as the output, is called as a executable, right? So when we want to run our application in a VM, we place the jar file here. When we want to run our application in a container, we got to place our application's executable output jar file inside a container. So I can do one thing. I can start a container. I'm beginning a container, say container 1, with a base operating system image. So I have a base OS with which I have started my container. And then inside this, I manually copy this jar file which we have produced and I execute that and start the application. So a few very important things about containers. Containers have image with which they start. How we have a VM image, like that we have container image. A VM can be started with a Windows image. A VM can be started with an Ubuntu image. So this is just base operating system image with which we are starting the virtual machine. Once the virtual machine is up, you go ahead and put your application, libraries, dependencies, everything inside it. And then you execute commands to build that executable and run that application inside the VM. Same way we can do it with this as well. So any application which can run in a virtual machine can be containerized. It's not that, like a lot of people have misconceptions that databases can't run, heavier applications can't run in containers. It's not like that. It's how you containerize the application. If you're designing it better, then any sort of applications can run. There is no such limitation like only web application can run in containers. That understanding is completely wrong. When containers came into the market, yes, certainly they came up to support stateless application, but with time, industry also understood that only supporting stateless application can't be the solution because our application is made up of multiple pieces. If I have a stateless front end, then I have a stateful backend. So we will need to support both in containerization format. So today we would be using a stateless application like a web application to run inside a container. I can even containerize my database and attach it at the backend, or in cloud, we have it as a service, so we can use it as a service. Azure SQL as a service can be used, and we can make my web app talk to my Azure SQL as well. You can do either of the thing. So whichever application we want to containerize, we can automate the stuffs if we do know the stuffs, how it is manually done. So let's understand how we would manually create a container with our proprietary application. So when I'm manually, this is a manual process I'm talking about, then I would automate all the steps here with a Docker file. I'll write a corresponding Docker file for it. So manually, I'll start my container with basic operating system image. That is what you do in a VM as well. So I start a container. It will just have base OS and nothing else. And inside that base operating system container, this is my container C1, which I have started with, say, Ubuntu, say 1804, for example. Then inside this container, I got to place my entire code. So what we would do, we would go ahead and git clone the code, copy the code, and our code would reside. Then you would go ahead and install some libraries and dependencies. So what you execute, you do app install. You execute commands like apt update. Apt is a package manager for Ubuntu. In case I'm using RHEL, then I'll run yum. If in case I'm using like how we have Chocolatey for Windows or Brew for Mac OS, apt is a package manager which helps us in upgrading package, installing package, deleting packages on Ubuntu operating system. I go ahead and update. I execute this commands where I execute this command inside the container which I have spin up. I execute the command inside the container where I have spin up. And then finally, I'll do a Maven build here. And obviously, when I do a Maven build, the output jar would be produced. And then I can execute. Here, I'll execute the jar. Then my container would have a process of this application up and running. So container has an associated primary process, and we can have several secondary processes which run inside the container. Very important point here. Container's life cycle is tied up to the primary process of the container. That means if my primary process is dead, my container would die. My container would die. If secondary process is killed, there is no impact on my container. But if the primary process is getting killed, my application dies. So every application has a starting point. That is the primary start point of your application. Inside that, you may have secondary threads which do a lot of other actions. But if those secondary threads are dying, my application may not have impact on it. But if my primary thread dies, that my application goes down. In a virtual machine, what happens? If your app goes down, your VM doesn't go down. Your VM has a stable operating system running on top of which you have started your application. So if your app is going down, your VM will not go down. It could be like a web application which is listening on port number 80. If that is going down, you may not able to reach the application on VM IP address on port number 80. But in case of containers, because containers don't have anything, it's just having that application running inside it. The operating system with which it has started, if you see, I have written it outside. There was an intention of writing this Ubuntu 18.04 outside because our containers don't have that OS sitting inside the container. It is actually sitting on the host machine. And from there, it is booting up that container. So this base image is just helping to boot our container and start a primary process inside it. I'll just spend some time in explaining this basics. Let me start a virtual machine. I'll start with installing containers as well with a base operating system image. Because a lot of time when we go ahead and explain the further steps, these things are unclear in the mind. So let me just start with it. I'll just choose my favorite region of East US2. I'm picking up Ubuntu 18.04 operating system, East US2, one virtual CPU, 1 GB RAM, a basic, very small operating system image taken, and a one virtual CPU, 1 GB RAM is sufficient. I'm spinning up a VM here. It's not a container, it's a VM. And I'll provide a username and password. Password didn't match. Amazing. Then the first one is wrong. That's the standard password, which I always use. I'll just go ahead, review and create. I'm just opening port number 22 on this VM. Now what we would do. To understand this part, first we need to understand how containers work because we would be containerizing our application. So I will pick up a virtual machine. Right-hand side, I'm drawing what I'm doing at present. This is my VM in which port number 22 you would SSH to. We will go ahead and install Docker. So I have operating system in this. And then I would be installing Docker so that we can execute the Docker commands. Docker runs like a daemon process. It's a service which would be up in the server, and you would be able to run containers inside this. So don't worry, Pavan, we would be connecting our Docker containers to the applications, the backend databases. We would do that. So this process should be up and running. Then I would be able to create containers using Docker commands. So I would be executing commands like Docker run, and I would start a container. Now, if I have a proprietary application, then I would have a corresponding image. So Docker run, I want to start it as a background container. I don't want to interactively get inside container, then -d I use. And I provide the image. Say my image is app1 image. I provide this, and inside app1, I would have already provided what is the primary process with which this container would start. So there should be a starting point of a container. Otherwise, there is nothing which is running inside the container, then container would not start. Try and understand that on this OS level, there is a process running. That is the primary process which is actually running. And that you see it as container C1. From the container level, when you're seeing a wrapper on top of that primary process. But actually, where is that primary process running? That primary process is running on the operating system level. So on OS level, it's just a process, but it is an isolated process. It has its own process isolation. It has its own user isolation. It has its own network isolation. It has its own kernel isolation, storage isolation. And that's the reason containers, when we run multiple in a system, they don't interfere with each other. We can dedicate some amount of resources. So what containers are providing? Containers are providing us two benefits that if I run a process inside a container, it would have isolation from other processes which are running in that system. And we can limit the amount of resources which we are planning to use inside this container. So I have a container which is running a process. This process is nothing but end of the day OS process only. But I can provide an isolation box like this so that this process doesn't see another container's process. This is red container is another container and it has another process running. These two will not interfere with each other and I can dedicate one virtual CPU, 500 MB of RAM. So what is this? This is limiting of resources. What is this box called as? This is called as isolation. So we have to create a container which would be going ahead and having a primary process running inside it. So in case it's a Java application, I will execute my jar. In case it's a .NET application, I'll execute my DLLs. So that execution is important. So here you are building the code, you are producing the jar file. So what happens to build the code? You need a lot of stuffs. Like I need Maven to build. I don't need Maven to run my application, but I need Maven to build my application. Like that, there would be a lot of dependencies which are just needed during the build phase, and they are not needed during the execution phase. But what I have placed everything inside the container. How we take a VM snapshot, we take an image of the VM, and that image becomes our proprietary image, and with that image we spin up several virtual machines. Here also you would do the same. This is my standard container which I've created. Now I'll take a snapshot of this container. The command to take a snapshot would be docker commit, and I would create an image out of this, say image 1. Now next, when I start a container, I would execute docker run with image 1. Then what would be there in this container? This container will have my code. It will have all my dependencies and libraries. This container will have Maven, and it will also have the jar which was produced. So this container is very bulky. Maven is not needed. What is my intention? This is the place where I'm actually running my application. My users would access my applications running inside this container. That is my intention. Maven needed during runtime? No. Then why are we keeping that? Other libraries, dependencies, are they needed during the creation, running of the application? No. But we are having them. Tomorrow, if there is a small bug in any of the libraries of dependencies, there is some security vulnerability, my entire container is exposed. It is vulnerable to attacks. That's the reason what we do. We create two-step build. In one step, we will build our code. And in the second step, we will actually build the container image, which we would be going ahead and deploying. Okay. So here we, on the right-hand side, we have understood that there should be a Docker type of software, a containerization platform, which gives us the ability to create container. What ability it gives? It gives the ability to isolate our processes and limit our processes so that the processes which are running inside the container don't interfere with the other processes running in the operating system. So if we don't containerize, those processes can trouble each other. I can't guarantee one virtual CPU 500 MB RAM to a certain set of processes. That intelligence is not there on the OS level. That's the reason we were bound to create a closed box, isolated box. On the kernel level, it is called as namespace. We create namespace, and inside namespace, using two important features of kernel is used here. Namespace gives isolation, and control groups, also called as C groups, gives us the capability to limit amount of resources. So that we have understood. Now, we need to understand if we have a Java application or a .NET application, we would build it, produce a jar, and then in the next container, we would only have that jar in it. We will not bring Maven, we will not bring any other dependencies, we will not bring any other libraries. Whatever is needed during runtime, that alone we would be placing in that container, which we plan to actually expose to our users, which they would be accessing. So this should be our first phase. Phase one, to build code. So I can build my code on a virtual machine as well. I place my code on a VM, I execute Maven build command. Jar is produced inside a VM. I can do that in the container as well. Place your code inside the container and execute the Maven build command inside the container so that your jar is produced inside the container. So we would be doing the second method. We would be creating a container. In that we would put our code, and then we would execute this jar Maven build and produce the jar inside that, or we would do a .NET build and produce the output there. So I'll halt for a minute. There is a question. Alok says, what if some process need more resources from kernel as we are limiting? So Alok, because we are limiting the amount of resources on the process level, if you need more than what you have, now tell me that host machine is there on which you have created virtual machines. Virtual machines also you specify. Now, when I created a VM here, I mentioned that I need one virtual CPU, 1 GB RAM. In case my virtual machine is needing more than this to run, what happens in that case? If resources are present on the host machine, it will give me. If resources are not present in the host machine and continuously my application, my virtual machine is going and asking for that much of resource, my VM would be in trouble. And we would go ahead and have that VM going down. Exactly the same. If you have told I'll use one virtual CPU and 500 MB inside a container, and you are asking for more resources, then for digestible amount of resources, if resources are present, others are not using, you would get that. But if you want to go beyond something which you have asked continuously forever, it's not like a spike, it's like a continuous ask, then that container would be killed by the kernel. Kernel is going to kill the process. Kernel doesn't understand that it is running inside a container. For kernel, it is a process who had asked a box. What is that box? That box is the boundary of limit of process. If that limit is continuously increasing the size of the box, kernel goes and kills that process. So let me show you one thing here. This is a bare virtual machine in which nothing is there. Docker is also not there. Okay. So I'll go ahead and install Docker first. For that, because Mamta user is not a super user, it's a general user. Like when in Windows we run an application, we run it as an administrator. Here, package installation, package upgrade and all has to be run as an administrator. I'll go ahead and update because this is a fresh system. The system is completely fresh. The virtual machine has started right now. So thumb rule, first update the OS and then go ahead and install the packages. So update is done. Let me know if the font size is good. So sudo apt install docker.io. This is the name of the package of Docker. It will get me Docker client. It will get me the Docker server side as well. I'm writing -y so that it doesn't prompt, do I need to install, do I need to install. So -yes for giving yes for it. Meantime, when the Docker installation is happening, let's see if we have any questions. Akshay is asking, is Docker limiting resources is not compulsory, right? See, Akshay, it's not compulsory. So, but there is a limit. Understand that. Don't say Docker is limiting resources. It's the kernel which is limiting resources. Docker has nothing to do. Docker is just a set of library functions who go and relay our request to the kernel. So I'll tell you one story. When I was in Alcatel-Lucent in 2011, we were running our applications in virtual machines. In telecom, hardware is very, very costly. So what they told, we will start using containers. And that time there was no Docker containers in the market, 2011 timeframe. Linux containers were there. So I literally had to run 20 commands to go to the kernel and tell that you have to create network isolation, you have to create process isolation, you have to create user isolation. Docker came up with simple APIs with which Docker told you just run Docker run command and we would go ahead and create all those isolations on your behalf. So Docker is not limiting the resources, just to correct your statement. Kernel is limiting those resources, but yes, it's not compulsory that you go ahead and start containers with limiting resources. But in every operating system, there is a limit to which a process can eat up the resources in the system. So a container is also a process on the OS level. It doesn't have the capability to eat the entire amount of resource on your system. Okay. So don't worry, even if you don't limit it, you can keep asking for the resources till the time resources are there in the system. If you go beyond some amount, your process would be killed. Hopefully, Akshay, your question is answered. There is another question from Shirish. Are the resources allocated dedicatedly or shared during that time? Can I assign 1 GB RAM to 3 images on a host and of 2 GB RAM machine? The virtualization concept comes here, Shirish. In the hardware, certainly you are having just 1 GB RAM. I'm just saving this picture in case we have to come back. So what is virtualization? Here also, it's like virtualization only, right? Hardware is there, which is having 2 GB RAM. When you are creating an isolated environment, you are saying that in this isolated environment, I'm dedicating 1 GB RAM. So your question that can I assign 1 GB RAM to 3 images? First of all, images are not running instances. Images are just snapshot of a container or a VM. A running instance is a container or a virtual machine. So I can assign 1 GB RAM to a running container. Yes, I can do that. But this is dedicated to this container. I can't say there are 3 containers which will share this 1 GB RAM. No. Then you have to be very specific that I would give, say, 200 MB to this, 300 MB to this, and 500 MB to the third container. You should be very specific. Okay, so you can't say I have 1 GB RAM and 3 containers will share across that. that possibility is not there. Okay, and we don't dedicate resources to image, we dedicate resource to running container. Image is a snapshot. It's not a running instance. It's just a copy of a container. When you execute that copy, then a container starts. So coming to security of data, how it works, we will talk about data security in a while, Manikant. I'll just put a hold on your question. Let's understand processes. How the data isolation happens, I'll try to cover that as well. My focus today is more to spend time on containers itself because the topic is Dockerizing our application. So if we know the Docker basics in a better way, containerizing our application would be intelligently done. So now we understand that amount of CPU, amount of RAM we are dedicating to a piece of container. Let's see how do we do that. So I'm here. I have installed Docker. I can go ahead and see the status of my Docker service. Systemctl command status. Is my Docker process running? It is active and running. This is the process ID of Docker. This is the process ID of Docker. But at present, Mamta user can't execute Docker commands. A user to execute a Docker command needs to belong to Docker group. Mamta doesn't belong to Docker group. These are the groups to which user Mamta is belonging. So I'll do one thing so that I don't have to do sudo in every command because I'll miss that executing with sudo. So for my benefit, I'll go ahead and add Docker user Mamta to the Docker group. So what command I'm executing? I'm saying sudo user mod. Mamta user doesn't have capability to give extra permission to Mamta user. So I am becoming root user with sudo and I'm saying user mod, modify the user, append to group Docker. Which user? Mamta user. So this is my username. This is my group name. I'm appending Mamta user to Docker group. Is she added? She is yet not added. Why? Because that will take into effect when I restart my terminal. So I'll go ahead and again connect to my virtual machine. I've exited from the virtual machine. Oh God. Password went wrong. Yeah, cool. Now I should be able to execute Docker commands. This is the first Docker command, Docker PS or Docker info. This we run and we check if we are able to run Docker commands. Now I want to show you something, a very 5 minutes I'll take. I want to make everyone understand that the process which is running inside a container is nothing but a process which is actually running on the OS level. If that understanding is correct, then our containers concept is very clear. It's just that that process is isolated and process, if we are limiting, then it is limited. So I'll execute a command, docker run. I want to run that container as a background process. And I have written T because I want to start terminal as a primary process. I'm picking up Ubuntu image and I'll start bash as the primary process. I need to specify something as the primary process, otherwise the container will not start. Container is nothing but a process instance running. So if a process is not running, a container is not running. From the OS level, it's a process running. From the container level, it is a container running. So container is just like a wrapper on the top of the process. So I'm starting a base operating system container, Ubuntu container with bash primary process. Image was not there locally, so it is pulling the image from hub.docker.com. Why it went to hub.docker.com? Because as soon as you install Docker in your machine, if you have internet connectivity, the default registry server which your Docker daemon looks to is hub.docker.com. So image is pulled and a container is started. If I do Docker PS, I should see a running container. 20-second back, it came up and container is having bash. CMD tells us what is the primary process running. So this process we feel is running inside the container, but actually it is running on the host machine. I'll try to show you that. If I do PS, this bash process, where am I executing PS? I'm executing on the VM. This bash process is on the virtual machine. The bash process with which we have connected this terminal bash with which we have logged in with Mamta user to Docker VM is having this process ID. Now, I'll execute a command to grep for all bash processes running in the system. Do you see this? A bash process is running with root user, and the process ID is 15648. This process is the one which is actually running inside the container. How do we confirm that? Let me go ahead, start another container. There are 2 containers now. So totally how many bash processes are there? 1 bash running on the VM with which we have connected to the SSH terminal. 2 bashes, one bash running at each container. 1 bash running in this container and 1 bash running in this container. So if I grep for bash, what would happen? Do you see this? And do you see this? So 115.15535 is the operating system bash, which is running as user Mamta. I connected with via SSH as user Mamta. This is running as root user because the process running inside the container runs with a default process runs with root user. So this is running with root user. This is that bash. And this is the second bash which we have started. So I want you people to understand that we feel we are running containers, but we are actually running processes in an isolated environment so that they don't trouble each other. And those processes are running on the same operating system level. If I run process individually on the OS level, they are not isolated, so they would trouble each other. But because I have containerized, I have a lot of containers running in it. And that's the reason I am able to isolate them and they would not trouble each other. So I have 2 containers running at present. Now, if I want to deploy a web application inside a container, what will I do? I'll go ahead and connect inside the container. Taking you back here, I have started this container C1 with Ubuntu latest. I have started container C2 also with Ubuntu latest. I'm not limited. So I'm just removing this. So there is only 1 copy of Ubuntu latest with which this container has also started, and with this container has also started. Ubuntu latest is residing in the file system on the host machine, but 2 containers have booted up. This portion, the box which is there, that is the read-write layer of the container. This is the read-write layer. An image with which the container starts is the read-only layer inside the container. This can't be modified. Read-only part is immutable. And the container boots with this. So I've booted with a read-only image. This is my image with which I have started. And whatever I do inside the container would be placed in the read-write layer. Now, if I want to connect inside the container, at present, there is a bash process running inside this container. There is a bash process running inside this container. So coming to the OS level, bash is running, but isolated. Bash is running, but isolated. I would connect to this bash process and I can go ahead and execute it. But I had started this bash process as -d. So when you start a process in a detached way, you can't attach to that process. Or else I should have executed Docker run with -it. This is interactive terminal I'm creating. Then I will be able to connect to this. But I had not started that container that way. That's the reason I will not be able to connect to this bash process. This is my primary process. I will start a secondary bash process and I'll enter inside this container. Now I'll ask a question. You people have to tell me the answer on the chat. If I kill the secondary bash process, what will happen to the container? Will that container exist or it will die? If I kill the secondary bash process, will my container be still existing or it will die? Divakar says exist. What about others? Exist. Awesome. Even if I kill my secondary bash process, my container would be there. But if I kill my primary bash process, what will happen to the container? Second question, if I'm killing my primary bash process, what will happen to my container? Alok says container would die. Yes, correct. So I'll show you two things. This is a bash process with this process ID. I'll do Docker PS and I'll go ahead and execute a OS level command to kill this process. Do Docker PS. You are left with one container. This Gallant Thompson died because this bash process was the primary process of this container. Okay. So our understanding is correct. Now I'll get inside this other container with starting a secondary process. So I'll say I'm executing interactively a terminal process inside this container and that terminal process is bash. So I'm creating a secondary bash process. If I do PS, you can see the process ID is 9. Primary process ID is always 1. Primary process ID is always 1. 9 is a secondary process ID. If I type exit here, nothing will happen to my container. It's still running. So I am inside the container with a secondary process and I would go ahead and do an apt update inside this container. Where it is writing in the read-write layer of the container. I will go ahead and install Nginx. It is installing Nginx package inside the container's read-write layer. If I go ahead and delete this container, someone was asking for data persistency. So answering your question right now, the data which is residing in the read-write layer is non-persistent. This is ephemeral in nature. So if I delete my container, this data is lost. And that's the reason you take a snapshot of this and create an image out of it to make it permanent. What is image? Image is read-only. It is immutable. So from a mutable part, you commit and you create an image and that produces your permanent image. So if I am installing Nginx now here and I'm committing this image, what happens? I'm committing this container. I produce an image. What would be there in this image? OS plus Nginx. Everyone agrees to this? Will I have OS plus Nginx in this image one, which I create out of container one? We can start, Divakar, we can certainly start a container with -it, but normally the containers are started in background because some tool starts it. So I can certainly go ahead and say Docker run -it and start the container. It will interactively take me inside the container. I'm just giving some junk over here to install Nginx. Nginx is there up and present in the system, not up and running. So I will go ahead and do service Nginx start. Check the status. Nginx is running. Let me see. I don't think I should have curl on this host. So I'll go ahead and install curl. And then I'll do curl localhost. Welcome to Nginx page is there. My application is listening on port number 80 inside this container. So now I'll go ahead and type exit. This is a secondary process, so nothing would happen. To answer the question that can we start with hyphen IT? Yes, we can start with hyphen IT. I'm starting this container with hyphen IT. It's that interactively I'll directly land to that container. I don't want to execute command then and there. That's the reason I started hyphen DT. Okay, Divakar. So I will press Control PQ and come out of this container to leave that container up and running. Two containers are running. My container this has a read-write layer which has Nginx in it. So I'll go ahead and do Docker commit. I'll show you how to use help commands as well. Any command, what all parameters can I supply? You can look with hyphen hyphen help. Like Docker run also, you can do hyphen hyphen help and look for all the options. I would commit and create an image. So commit this container and create an image named Nginx version 1. It is producing a image out of that container. If you do Docker images, now I have Nginx image and I have Ubuntu image. This is the base image with which my container has started. This is the image which I have produced. You can do Docker history on any of the images and look a little bit more details on it. So here it is not showing too much because we have created it not in that beautiful way. Otherwise, it should have shown a lot of things. Now coming back to our automation part. So what I did, I have started a container with Docker run. Then I landed inside the container. I did apt update. I did apt install. If I had a proprietary HTML file, I would have copied that file inside that container, or say I have some proprietary index.html, which I can create as well. And then finally, what we did, we went ahead and executed, we came out of the container and we executed a commit command. This we will automate. Okay, this we would automate. Now there are two questions which I would like to answer. There are two containers. This is also running Nginx. This is also running Nginx. Every container has its own network stack. So this container has an IP. This container has an IP. On this IP port number 80, I can listen to Nginx. On this IP on port number 80, I can listen to Nginx. So containers can have the same port number. But these containers IP1 and IP2 are private IP addresses. I can't reach them from outside. This is my VM. This is my virtual machine's ETH0. If I want to reach this Nginx from outside, I will have to grab a port number on this host machine, say 80. And I would say that when you are reaching virtual machine on port number 80, I would forward the packet to this container on port number 80. This is called as port mapping, which we haven't done at present. So our container is actually not accessible from outside. Now your question. Inside the container, two containers can listen on port number 80. This is container specific port number, but two containers can't listen to this host port 80. Because on this host machine 80 is utilized by container C1. Then for container C2, I will have to pick any other port number 81. Application listens on 80. Nginx is made to listen on 80. That is anyways going to function inside the container. But how to reach the application from outside? I will reach a VM IP address on port number 81. Then I can forward my packet to container. Will take me to C2 on port number 80. And when I reach VM IP address on port number 80, it will take me to C1 on port number 80. Just let me know, Vinod, if your question is answered. How to decide request should reach which container? We will do that now. You have to tell. When you create a Docker container, that time we would see -p option and we would specify that. I'll say 80:80. This is host port and this is container port. That we have not done. That's the reason I told my Nginx container at present doesn't have connectivity to the outside world. Okay. So now coming to the part which we were discussing. There was one more question. How to upload images. Image upload, we will see how to upload image. Arijit only, right? And Thaninga had a question. If a container got killed due to primary process got killed due to any reason, how can you take a snapshot? So container getting killed and container getting deleted are two different things. Killing is just stopping the process. But the read-write layer is there. You can still go and take a snapshot. But when you delete, the process is stopped, plus we delete the read-write layer as well. So I never mentioned on stopping the container. I mentioned on deleting the container, the read-write layer will go off. Taninga, just let me know if that makes sense. So if container is stopped, still then you can go ahead and create an image out of it, okay? Don't take tension. Now, I would write a Docker file which will automate this image creation process, which would automate this image creation process. Now, in the Docker file, I will say with what container you want, with what image you would start. So from which image are you starting? We had started with from Ubuntu latest. Then inside the container, what you execute? I would run apt update. Inside the container, I would again run apt install. Inside the container, I will copy a index.html file. Inside the container, once the container starts, here I had started Nginx service. So I will say when this container start, Nginx should start as a daemon process. This daemon process to start. That you specify. And give this Docker file to Docker daemon. Docker daemon process which is running, it will pick up this Docker file and it would go ahead. We feel that we are not creating a container, we are not doing anything, automatically an image is coming up. But at the background, Docker daemon starts a container with this image. Inside that, it executes apt update, app install, it copies that index.html file. It remembers that I need to start Nginx daemon as the primary process. And finally, on our behalf, executes Docker commit, produces an image and gives that to us. What we feel we have automated. We feel we have automated the entire process. Who is doing on our behalf? Docker daemon does this part. Here, Mamta did this creation of the container, installation, and committing. She produced the image. Here, who is producing the image? Docker file is given to the Docker daemon. Docker daemon is producing the image with Mamta will use. This I would be using. So a way we have automated. How we automated? We gave the instructions to Docker daemon what to do to create that image. We told start with this container, execute these commands inside it, copy this file, and then produce the image. So now taking you to the actual part of this stuff. Let me see if I can make this project public. Sorry. Go to the project settings. So this is my code repository. Everyone can create a project in Azure DevOps, then they would be able to import my code to your Azure DevOps. So I have a project in Azure DevOps named Java Web App. Repository is there in which source code is present, in which a Docker file is present. Here I say, how do you start? How do you execute? What you run? All those things I specify here. We would produce an image out of this Docker file. We would give this Docker file to the Docker daemon to produce this image. That is our work. We are starting with this Tomcat GRE8 Alpine image. Inside that, we are running update command and addition of curl and few other packages like tar and CA certificate. Then we have to set few things. We are executing. I'm making a directory. I'm doing a curl, downloading this star.gz and all that inside the container. So you are seeing and statements here. When we have multiple runs, you want to combine all the runs in one go, then you can write and statements like this. I don't have to write run, run, run. Multiple run instead of typing, you say run. And when you give slash, that means the command is going to execute in the next line. And I'm doing an and. This is one command. This is one command. This is one command. I'm doing a CD to this particular. I'm going ahead and untarring the MySQL connector.jar. I'm checking the present working directory. I'm setting the, creating a directory, and I'm moving a jar file from this path to this path. And then I'm going to home directory, and I'm recursively deleting few things. I'm recursively deleting the unnecessarily stuffs which are created. I am exporting a variable here called as class path, and I'm adding a var file. So here var file is already produced and kept in the target folder. I'm placing it in Tomcat Web Apps, myshuttle.var. I'm copying the var file. So I had mentioned a copy instruction. You can write a copy instruction or add instruction. What are these instructions called as? The run command, the copy command, the cmd, the from. These are called as Docker file instructions. These are called Docker file instructions, the instructions which you write in a Docker file. So this is one sample Docker file. Let me show you another .NET Docker file as well. Are we all doing good? No response. We are not doing good. Say yes, no, something at least, guys. Understanding, not understanding, boring. Mamta, you're spoiling our weekend. Okay, cool. Thank you so much. So I need to have a Docker file here. Docker file. Yeah, this is the one. This is my .NET Docker file. I'm starting with a ASP.NET Core image. Arc is just for supplying arguments. Source, wherever I use, I can replace with a different string from the command line. I can run that. Working directory. Whenever we get inside a virtual machine, we land to a default path, our home directory. Like whenever Mamta landed inside that Docker machine, she landed into home Mamta. That's my default working directory. Inside the container, for the application to run also, you can set a default directory. Whoever gets inside the container would directly get into /app folder that you want to tell. So for that, the instruction in Docker file is called as work directory. You're setting up a work directory inside, and you're saying /app is my work directory. Now expose command. This you are saying that whoever picks the image, understand this, that image application would be listening on port number 80. Okay. So application is supposed to run on port number 80. So we write expose here. Copy. Some path is there from which we are copying some published stuffs and copying it where? Copying in dot. What is dot in Linux? Dot is present working directory. So let me pick this file snippet and go to I want to explain few things here. So from is telling the base image with which you are starting. Arg is just setting some parameters. Source you see here, that you can supply it from the outside as well. Work directory, it sets the default directory. So how it is, when you executed this file, the Docker daemon executed this file, it created a container with this base image. It set this variable and it set this working directory. That means it went to cd/app inside that. And now when you copy some source to a destination, which is dot, this thing actually gets copied. Dot is our present working directory, which is nothing but /app. So this would be copied in /app. And we are also stating that whenever you start the container, there are two things, CMD or entry point. I can use either of them. Both are used to start a primary process inside the container. You are saying that .NET execute this DLL. Whenever the container starts, execute this. So that's the starting primary process of my container. Okay. So two different Docker files we saw. In one, we saw a few set of instructions. In the other, we have seen a few other sort of instructions. Okay. Now coming back to this. So this is a Docker file. I was saying I'll also talk about another tool called as Docker Compose. So what you do with the Docker file, this Docker file, if I pick up and I go, I would be able to build image using Docker build command. I would execute Docker build command, image will produce. But we can let the CI/CD pipeline to build the image for us, or else we can also use another tool called as Docker Compose tool. Docker Compose is a tool which helps us it can do quite a few number of stuffs. It can build image for us, and it can deploy containers in the same host machine. So you would install Docker Compose tool, and when you say Docker Compose up is the command, whatever you have specified in the compose YAML file, it would build and it will deploy that container. If you have two containers, it will deploy both the containers. If you have specified one container, it will deploy one container. Docker Compose has capability of working with multi-containers. So when we have an entire container stack to bring up and test once in the dev environment, we use this too. So we do Docker Compose up and containers, what we have specified in the YAML file, if the image is present, it will pick the image. If image is not present, it will build the image, and then it will go ahead and deploy the container for us. So we would be using a Docker Compose tool to build and deploy our image. We would not go ahead and execute the Docker file. We would let Docker Compose build the image. So we would be building our image and we would be deploying our image. Let's see one of the Docker Compose files. So Docker Compose version is this. Services tells How many containers? Services are nothing but microservice. A container is a microservice, right? So I have one microservice called a CI build. We have here, you can see a CMD, a working directory, a volume, and an image. These things you are supplying to the Docker Compose file. So what it does, it builds the image with this. Here you can see it is building, and it executes this .NET restore. It will do this .NET publish, and it would go ahead and publish this object file here in this path, -o. In this path, it would publish. So it is starting the container with this image. We have specified the image with which it can start the container, and it would go ahead and execute these commands inside the container. And it is publishing this output. So this output is present. You want this .NET repo to be public? Okay, I'll go ahead and do that. 1 second. Let me see the project settings. Yeah, so you have this as well in the public. Now coming back to the Docker Compose file. Here I have specified the image with which I am starting, and I'm saying what I'll be doing. Now, volume helps us in mounting a volume inside the container. Volume command helps us in mounting a volume inside the container. Someone who was asking about the data, that time there was a question that if we have some data residing outside, how do you mount that data inside the container? So how we mount disks in virtual machines, same way. You have a mount point and there is a disk. Whatever is there in the disk would be available in this mount point. So when you start the container, you give -v, you specify the source path, and you specify the :destination path. The destination path is the mount point. So when in the Docker Compose file, you wrote volume, the .src, you see here, this dot is mounted inside the container in /src. What is dot? The present working directory where the container has started, from where you have executed the Docker Compose up command. That entire directory is mounted inside the host machine, inside the container, sorry, my bad, in path /src. This image is my private image, which I have published in my hub.docker.com. This is not the path of the image. This is my hub.docker.com's credentials, and this is the image which we have produced. I've made this image public. Others can also use it. Okay. So Mamta J, ASP.NET Core build. So this image will be picked from hub.docker.com, and it will start a container by mounting the present working directory inside the container in /src. It will also set the working directory to src inside the container, and it would execute these commands inside the container. That's the work of Docker Compose tool. So Docker Compose tool, what it does at the end in this has published this. So I had mentioned some time back when we were discussing that there would be 2 steps. Sorry, this Teams doesn't let me change my screen sometimes. Let me see if this was the picture. Coming back to this, first phase, we would build the code. Second phase, we will build the container image. So first phase, we are building the code that we have done. We have built our code and we have published this to /obj docker publish. We have published it. Now, I need to go ahead and create a container image out of this. So where do we do that? Let's go back to our repository. There is another Docker Compose file you people will see. This file is called a CI build, in which we were building our code. The other Docker Compose file is this. So let me pick up this Docker Compose file. So this Docker Compose file is saying what? It is saying that there is one microservice. So the name of the container is this. The image which is given, but here there is a build as well. So last time, let me compare the other file as well. So I'm just picking up smaller section till here. I want to show you the difference between this image instruction and this image instruction. This image instruction in the first YAML which we saw just has image. We don't have a build instruction. So it picked up the image. It picked this image. But in the second one, image is there, build is there. We are asking Docker Compose to build this image. How it will build this image? It will go to this path. There is a Docker file. Pick that and build it with Docker build command. We are saying that to our Docker Compose tool. Go ahead and build the image and then deploy your container. Okay, so it will do two things. It will do Docker build and it will do Docker run. Here it just went ahead and executed Docker run, created container, and inside container it executed this and published that output. So there is a difference between this Docker Compose file and this Docker Compose file. This is building and running the container. This is just running the container by pulling the image. Everyone understands this? So wherever you see build, that means this image has to be built. How we will build? There is a Docker file where in this path. Path is mentioned as context. Let's go and see. That was the Docker file which we had seen. It mentioned under SRC in My Health Web, there would be a Docker file which you have to build. Had we not seen this Docker file? So this Docker file would be picked up and we would go ahead and create an image. And that image will have this copied. Do you see this? Where this was produced here. So in first container, which we created, we build our code. In the second container, we have built the image of our Docker container, which is going to deploy, and that has this code in it. This is my code executable, and I'm running that executable during the startup period. If these three files are understood, we are done for today. I'll not close the session. I'm not saying that, but these are the main 3 points to be understood. So can I have a quick yes or no in case we have understood the entire section? Showing a Docker Compose file for your Java app. Okay. AK, I'm Mamta. I'm not ma'am. If ma'am was short form of Mamta, then I'm okay. I'm showing the Java app as well, Sirish. Don't worry. So in this Java app, I'm actually creating two things. I am creating two containers, my front-end web container and my back-end DB container. Both the things I'm creating in containerized environment itself in this application. I don't have a back-end database running outside. I would have two containers, one web app container and one SQL container. Okay. Now, first container web is coming up with web image. which is built from this Docker file, And it has some port mapping and depends on. I'll explain this. So let me pull this Docker file here. Docker compose file, sorry, my bad. So two microservices would get created, one web container. So this is my C1 and my DB container, which would be my C2. In this example, C1, C2, both are running in containerized environment. I'm saying create an image called web from this Docker file. Here I'm saying image DB from this Docker file. There are two different Docker files from which we are producing the images. Okay. Now, here you see I have just written expose 3306. And here I have written port. So there are two things. A container listens on 80 and is tagged to port number 81. This is my web application. And this is my DB container. DB container listens on 3306. For DB, I don't need exposure outside. But for my web application, I need exposure outside. So here we have made our application to run on 8080. So I'll take 8080. And on host, I'm asking for 8081. So I'll take 8081. So web application would be exposed outside by stitching up this port mapping. And whenever web talks to your database, this database communication, when it happens, it will happen on 3306. So here you are just telling, this is for your information. DB container would listen on 3306. Here you are saying, go ahead when you run -docker run command, you need to write 8081:8080. What did I mention? What does Docker Compose tool do? It executes Docker build command on our behalf and it would produce image. After that, it would execute Docker run command and create container. Here, Docker run command will run. That time it has to do this. That's what we are telling. In this, nothing like that would be there, but we need to know port number 3306 is the one with which application will actually listen on. That's the reason this is for your information. Now there is another depends on string. DB needs to come first, then only web can come. How can you specify that? This Docker Compose file will build image. So it first builds web image, then it goes ahead and builds DB image. It does two builds. Okay. First step, building web image. Second step, building DB image. Third step, it will first bring Docker run for DB. Then it brings web as fourth. Why? DB has to come up before web because web depends on DB. That's the reason this is the name of the microservice which you are specifying. I had mentioned that Docker Compose helps us in setting up a multi-container stack. So if I have to bring stack, but there is an order of initialization, we can use that depends on string. So in case of production, we normally use this Docker Compose file because Compose just not just builds it, but it would deploy and check as well. And if containers are running fine, then we move on to the next stage where we go and push the image. So I built the image and I deployed as well with Docker Compose. Two-in-one things can happen, Akshay. And if the container didn't exit and it was running, then I push the image to my container registry. That's the reason we do this. Here in the Java application, container and DB both are running in the same containerized environment. Amit, in the in the .NET application, DB would be running in Azure SQL. That connectivity can be done. Okay. Now, Arijit had a question which I had not answered. So I'll answer that question before moving ahead. I understand that you're using arg for the argument and also specifying entry point, which can be used during runtime as well. So arg is just for supplying some argument for the Docker file. Suppose you have used some variables inside and you want to supply parameters to it, you can do it with arg. Entry point or CMD tells the primary process which would run. Okay, that is depicting the primary process which we would run. Yeah, we would see those Kashtub, or I should address you Rajendran. Rajendran, we would see that. I'll show you the string. Okay, so this part we have learned. Now getting back to this. So I have my Docker compose file. I have my Docker file, and we are building up the application image from that, and we are going ahead and deploying our application. That's the intention. Now, our intention is to automate this entire process. Our intention is to automate this entire process. To automate that entire process, we will go ahead and use our Azure DevOps for creating, building our image, and pushing our image. So you see here, I have a pipeline already set up. In few of the other sessions, I've already explained about Azure DevOps. The pipeline picks up an agent. We are picking up an agent, Ubuntu 16.04 agent, on which we would be doing the Maven build, producing an image and pushing an image. And here we have the source code. We are saying that this particular repository you're picking up, this is the pom.xml file. Okay, this is my pom.xml file. And here you are executing the, in this, you are going ahead and building your application Maven build you are doing, supplying the POM file, and you are specifying the package. You are building the Maven, you are doing Maven build. And then finally, you are going ahead and copying the var file. So whenever the build executable happens, it gets produced in that agent. The var file is present in the agent. But for the deployment pipeline to pick up the war file, we need to publish it at a specific place. So we are copying that war file to a directory. And there is a .sql file as well, which is present in the repository. That also we would copy and we would publish it in this target folder. Now our source code is present, our war file is present. We need to build the image and we need to push the image to our hub.docker.com or Azure Container Registry. Then in that case, we would be picking up this task called as build image. Build image task says we would execute build command with this src docker file, and we would produce an image called as web. Push task will push the image. We are saying you will do a Docker push, and this is the image which you are pushing. So there are two different things we are doing. Now taking you to the other sample. Building, pushing. Here also you're doing two things. Here you have an extra run service. Why do you have run service? In Java application, we had a single stage build. We had a single stage build. In Java application, you had a single stage build. You just specified that you are going to build the Java application and Java and .NET, sorry, Java and DB applications, we were building the image. But in .NET, we had two things. We had two different Docker Compose files. One was building the code and another was building the image. That's the reason there are two different tasks here. There are two different tasks. This task is building the CI build command, CI build YAML file, and this task is building the normal Docker Compose file. What were these two files? Docker Compose file was this, Docker Compose file was this, and the CI build file was this. So two different tasks. So in case you want to have a two-stage build, then like this you would be executing. Java application shows a single stage build. Here it shows a two-stage build. Okay. And push is common in both the cases. And you can see publish artifact is also common in both the cases. Publish artifact is a task which publishes the executable or any files to the release pipeline so that the release pipeline can pick that up. That's our intention. So here I'll go ahead and start creating our web app. So we can create web app from our say portal. We can create it from command line interface as well. We can create container registry from command line. We can create container registry from our this as well, from the portal as well, right? So we will see two different flavors. Let me go ahead and maximize, rather than maximize this, take this out. So this is my Azure Cloud Shell. Hopefully everyone understands what's Azure Cloud Shell. I would be going ahead and selecting bash because I would be executing bash commands here. We can choose a location in which you want to deploy the resources. I'm setting up a variable called as location. I will say East US 2. So I'm seeing the commands in my other screen and I'm typing because obviously I would also not remember all the commands. So for some time, the chat window is not visible to me, okay? So in case we have questions, just hold on. I'll go ahead and I will answer your questions after I finish the part. Here I'm giving a name for the resource group. I want to create an Azure Container Registry. I'm creating a variable for that. This is a random string I would add at the end of it because Azure Container Registry needs to have a unique name. Then I'm giving a name for my app service plan. I'll give a random generated name for my web app as well so that it comes unique. I'm picking up an example in which the SQL Server sits outside so that it is a little bit difficult to display. So SQL Server name I have given and SQL Server database name also I'm giving. So many variables I have created. So location, resource group name, Azure Container Registry name, app service East US was misspelled. Oh, thank you so much. Now it's correct, right? Yeah. Thank you for that. So these are the variables which I have created, which I would be using in the command going ahead. So I've picked up a scenario which is there in your Microsoft Learning as well. I'm giving that link on the chat. I'm doing this exercise now. Okay. I will first go ahead and create a resource group. So I'm saying AZ group create, name of the resource group, and the location in which it has to create. It would go ahead and just create a resource group. After that, I'll go ahead and create my Azure Container Registry in this resource group, my ACR in this resource group. So AZ ACR create with this name, in this group, in this location, and I am using standard as the standard and premium. There are two different SKU sizes in it, and I'm saying enable the admin user credentials in it. So admin enabled is set to true. This will go ahead and create a Azure Container Registry. So let me take you here. We will be sitting here so that we come to know what all things have got created. I'll just go ahead and switch to Bash and just confirm in which account it is creating. Here the command is executing. I can just say AZ account show here itself. There are multiple subscriptions. So in this subscription, it has created. Okay. So later we will go ahead and validate that it has created in that subscription all the resources and the resource group. Now I will go ahead and create a app service plan first. So app service is platform as a service offering from Azure, which helps us in deploying our web application. It has a service plan associated to it. Service plan gives us the amount of resources we want. So there are shared plans, there are dedicated plans, there are free plans. We are picking up one of the plans and we are giving a name to it. We are saying that create an app service plan. And we would go ahead and have app service plan created and ACR. With this command, app service plan will get created. AZ app service plan create. If you go ahead and look at app service, when you're creating apps, that time you get this app. So I'm talking about this. Let me show you over here. Where is Central US? I'll just change it to a different region because it is not showing me Central US for app service. So here we would go ahead and select a plan. Once we give all the different parameters, it will give us the option to select a app service plan. So what is the benefit with web app? Web app is platform as a service. So here you can see, you can just specify a web app name. You can say what runtime I want to use. I want to run a Java application, a .NET application, a Node.js application, a PHP application, a Python application, Ruby. These are supported. And only these versions are supported. So platform as a service offering comes with operating system, comes with platform. You just put your code in there. So our responsibility would be just to manage the code. Our responsibility is not to manage the platform nor the OS because it's not infrastructure as a service offering. But I can't go beyond these options. If any of these options are there, then only I'll be able to create my web app here. So here you are specifying a web app name. If I want to deploy it in Docker containers, I'll say Docker containers, Linux container or Windows containers, you can choose. And then you can choose a service plan over here. You can choose a service plan over here. Okay. So that is what we would be doing here. So we have created an app service plan here. Now we would go ahead and create a web app. So let me go ahead and it has not copied the command completely. Let me just, I'll explain this command in a while. Just give me. So we are picking up cool. So I'm saying AZ web app create, name of the web app, resource group in which web app would be created, which service plan it would use, and I would be deploying an image. We had radio button, container or VM, and we are just picking up a dummy image so that our application comes up. So we would go ahead and execute this. A web app would be created with this. Now let me take you to my subscription and show you the resources which have got created. What was the name of the RG which we created? Yeah, this is the one. So in this, a app service plan is created. A Azure Container Registry is created at present. This is my ACR, and you have the service plan as well. With this command, a web app will also come up. In some time, you should have a web app as well. Now, we need to have a container image, which is present in our Azure Container Registry. We would be pushing an image with name My Health Web. So I'll create a variable called as image name as My Health Web. When we push the image, we will push the image with this. That's the reason I am setting that. We can set the container's image to this. We would say, see this command. It's a lengthy command. Let's dissect this and understand. We have picked up a standard web plan. It's not needed for picking up the standard web plan. In dev environment, you can go with shared as well. Okay. So here you are saying you are setting configuration for the web app. You are setting the container configuration, the name of the web app, the resource group. You are specifying the Docker custom image name as this. This is the custom image which I'm providing. What is my custom image name? My Health Web. Where it will get the image from? The image would come from Docker Container Registry server URL. What is the URL? My ACR name dot Azure ACR dot Azure Container Registry.io slash this. So whenever we name an image, the image is always named as registry slash image name. Like the ASP.NET image which Alok was asking, I had mentioned that Mamta J slash ASP.NET Core. ASP.NET Core is the name of the image. Mamta J is my Docker registry. So here my registry is this. My image name is this. And I have specified the registry server's URL here. So you would supply the image name and the registry server's URL, and you would go ahead and say that this custom image would be picked up from this location for deploying this web app as container. Let's execute this. It says no credential is supplied to access the Azure Container Registry. So it is trying to look up for it. It has set these things. We had enabled admin login for our Azure Container Registry, and that's the reason it is able to fetch these stuffs. Now, our front-end part is all set. Web app is up. Image placeholder is also up. Okay. Image placeholder is also up. Backend we need to create. So I'll go ahead and first create a SQL server. SQL server create the name of the SQL server, the resource group in which it is created, the location in which it is created, the admin username and admin password. The SQL server will take some amount of time to come up. Once the SQL server is created, we will go ahead and create a database in it. And we would also enable. So what we are trying to do now, let's picturize that and understand. So this is my, oh shit, sorry. So this is my Azure Cloud account. and this is my Azure DevOps account, okay? In this, I have a project residing in an org. In that project, I have repo. So I have a Java project and I have a separate project for .NET, okay? Don't get confused. They are two different projects. They will have separate pipelines. We are executing this exercise now. You have repos here. You will have pipeline section in which you have created your CI pipeline and the CD pipeline. Both are there. Here also you have pipeline services and in which you have CI pipeline and you have CD pipeline. We saw the CI part in both cases. How do you build and push? So to push, you have Azure Container Registry. We created this. Here you will have repo, a .NET repo. You are doing a .NET build and a Java repo if we are doing the Java project. In the same Azure Container Registry, we have repo 1 and repo 2. In this, I will push my image for .NET applications build, and here I will push the Java applications build output. I have also created a web app. I will just deploy one. So I'm just creating one web app. A web app which has an associated service plan with which I get amount of resources defined for this web app. This web app is as Linux container. And at present, we have told that this web app's configuration has to pick up the container image from this repository. We have just configured this so that it can pick up this. Now for the backend, I am bringing up a SQL server now. In that, we will create a SQL DB. Okay. And then the front end should be enabled to talk to the backend. So we will have to tell our database that our front end will talk to you. That setting also we need to do. Hopefully everyone is good till here. So going to this, the SQL server is created. In that same SQL server, I need to create a SQL database now. Let's see. SQL DB create. Name of the DB, resource group, in which server, this server which we have created, and we have given some setting attributes over here. This DB would get created. After that, we can go ahead and enable our firewall rules. Firewall rule create. Firewall rules are not created on a DB level. A lot of time people make that mistake. They go to DB and then they see whether a firewall rule we have to create. On the server level, it will get created. And this is the name of the rule. This resource group, this server, we are giving the start and the endpoint IP addresses. From a specific IP to IP you can give. At present, we are giving 00. So now let's go back to our portal. Go to this and refresh this. You should have multiple resources residing here. Let me close this guy. Why it didn't create in the same resource group? Yeah, RG name, I'm writing RT name. Sorry. This, right? Let's see. Huh, it is there. Okay, I had not scrolled it properly. Okay. So we have an app service plan, a container registry, an app service, and a SQL server. In this SQL server, we have gone ahead and we have enabled in the firewall settings that we are allowing our Azure services to access. If you have specific IPs, you can give it here as well. we have this. So all the resources are visible here. Now, pipeline has to be edited. Everyone is good till here. Everyone understand what all resources we have created. The connection string part, someone was asking, the connection string which we have to set up, right? So you can go ahead and fetch the database connection string. So I can go ahead and fetch the database connection string from here, and I can set it in the web app. So there is a command to set the web app connection string. So we can go ahead and set that in the web app. So we can do it from the command line as well. We can do it from here as well. As I have done everything from the command line, I'll do it from the command line. So you need to copy here, go to your web app, and then in the configurations, you have connection string here, you would set it. So whether it is a Java application, whether it is a .NET application, you set it here, it'll pick that up. That is how you do it. This here. Here you have to give the connection string. So I'll do it from the this place. The connection string I'm writing it here. This is my source, the protocol I've mentioned. The SQL Server name is there. And I've given the SQL Server user ID, password, and all over here. So this is my connection string. Now I need to set this connection string in Azure's Web App configuration. So there is a command for that as well. AZ Web App config connection string. Connection string set. You're giving the name of the web app, you're giving the resource group, and you're supplying the connection string type. I'm saying that connection is done to SQL, Azure SQL. So I'm giving that, and I'm giving the name of the connection string, and I'm supplying the value. So this entire value would be fed in here. So this is how you do the connection. Okay. So I'm going ahead and setting up this connection. You should see a connection getting created here once that is done. A new connection should be native once it is done. Just refresh this page. See this? This got created here. So if you come here and create it manually, it's very simple. Give the name, give the value, and select where is your SQL. These are the options. So that is how you connect it. So any application, whether it is a Java-based application, a .NET-based application, any type of application which has a backend connection, we can do it from the same place here. Now, we need to go ahead and do a few things like in Azure Container Registry, there is a section called as access keys. On the access keys, we had enabled admin user. Okay, we had enabled this. So we need to just make a note of this password. We will just make a note of it. I'll come back to this page again. So record what all values. We will record the value of the server. This is my registry server. And this is my user. And this is my password. Why we are recording this? Because when the CI pipeline executes, that time we need to supply these parameters. That's the reason we can make a note of it. We can supply this as variables over there and we can use it. So we are done with the infra creation now. We would go to the build and deployment stage. So this particular thing, I can execute this pipeline for you and show that the build happens. We can go ahead and pick up our Azure Container Registry. So here, Azure Container Registry, I'll go ahead and pick up my subscription in which I have created. I'll click on Authorize. This would create a connection point. It creates a connection string for connecting me to my Azure Container Registry. So I'm saying go to container registry type is Azure Container Registry. And in that, I have this container in this subscription. Go and look at, you should find your ACR here. This is the one which is created. This is the one which is created. Let's quickly verify. Yes, this is the name. So I'm saying you would, and you would push it to this container registry. So build command is going to build and push. So I have updated the push section. Similarly, I'll go ahead and update the build section as well. So I'm just specifying the ACR name every places where it will be building and pushing. In this, I don't have to update anything. It's all good. Copying the var file also, there is nothing to update. pom.xml is already present properly. I don't have to do anything. I can go ahead and say save and queue. This is my build pipeline. This is my build pipeline. It would build a agent is picked up, and it would do a build of the image and push of the image in Azure Container Registry. So this is going to execute in a while. This is for the Java application. Here, I'll just do the build. In the deployment part, I'll show you the build and deploy for the .NET application. So Maven build is happening at present. We are in that task. After that, we will copy the var file and we will publish it. We will publish the SQL file as well. We will build the image and we will push the image to our Azure Container Registry. We have the details of our Azure Container Registry here. So this is one way of doing it. Let this task run. Everyone is good with this pipeline. Everyone understood what all tasks we are doing. Can I have a quick yes or no in the chat? Yeah. Let's go to our other .NET. Here also, I need to pick up my Azure Container Registry name and all that stuff. There's problem many a times. It doesn't reflect the resources which we have deployed. This problem is there in Microsoft Azure. What to do? Authorization is already done once, so it will not let me authorize once again. But it is unable to find, in this project especially, it is unable to find my file. Okay. Let me see, what else can I do? Do I have... I don't think. Okay, I can do one more thing. Let me create a service connection manually and see in case that reflects. So the service connection we can pick up from here. It would give me the subscription names and I can create a service connection with a different name. Let's try picking up that service connection. So it is trying to load my subscriptions. Let it load. Meanwhile, let's go and see our other pipeline. Maven build is still going on. So we are safe. Yeah, so let me go ahead and choose my subscription. I'll give a name for the connection, say Azure Connect. The default subscription which was showing up over there, with that, the ACR name was not coming in the drop down. The problem was that. Hopefully everyone has understood. This is the same subscription, which I've used in the other project as well, but that was not showing up. So this was pre-existing, so could be a possibility because of that. On a project level, a service connection is created. So you can't say that, Mamta, you created a service connection in Java project, that you can use it here. That can't be done. It's a project levels resource. We'll go ahead and edit it. And this time, let's give it a try to our luck. Azure Connect. Load ho ja. Yeah, ho gaya load. So run task will build this Docker Compose file. And someone had asked, Mamta, we would use Docker file or we would use a Docker Compose. Right? I mentioned Docker Compose. So here you can see we are using the Docker file, Docker Compose, and we are running. We are building the image, then we abort on container exit. So we can run the container in background as well to verify the stuffs. That's the advantage of a Docker Compose task. Build, again, go back and choose the proper container registry. In this, it would build the image, and we are asking it to tag like this. You can tag with latest as well. So this will produce two tags, one with build ID, one with latest. I've chosen that as well. In this, it has to push. The task push will push the image to Azure Container Registry. Push the latest tag as well. And DACPAC file, we are just publishing the DACPAC file. DACPAC file is present in this repository that I'm just going ahead and publishing it so that my release pipeline can pick. So I'm going ahead and saving and queuing this. So this has executed. Let's see. Maven build is done. Build success should be there at the end. Build success is there. Then after that, we have copied the war file. You can see this is the temporary agent which we have got, the Microsoft hosted agent. From here to here, you have copied the SQL file. And from here to here, you have copied and published the war file. This is the part where from where we would publish the artifact. So I've placed it in a location, and this task is actually going ahead and picking up that and publishing it in a place so that my release pipeline can pick up. Building image. Here you can see everything happened. It first went ahead and pulled this Tomcat image. After that, it went ahead and executed each command. The Docker file commands, all commands have got executed here. Look into each of the things. This step executed, this step executed, step 3 executed. Every single, we were creating a SQL directory, we were doing all these tasks, we were untarring, all tasks have got executed, and we have finally built an image. Image name is this. Web latest. This image we have pushed in this task. So we have connected to this Azure Container Registry, and we have pushed an image called as web. It should be there in our Azure Container Registry. Let's go back. In Azure Container Registry, you have overviews here, and you have repositories here. In this repository, now one repo should have got created for our Java application, the web. And this is our web image. This is our web image. Okay, this is our Java applications web image. Now, same way, when our other pipeline executes, that time we would have another image pushed. Let's go back to this pipeline. Push has happened. After that, some last finishing post jobs have been done. So this task is executed. I will not do the release because I have not created a web app for it. Otherwise, I'll just show you this. This is for my SQL. I'll go ahead and place it here. And this is for my web app. I can go ahead and deploy it individually over here. So here you can give the subscription where your SQL is there, where your web app is there. I'll do that for the, I had set the image name as My Health Web and I had not set the image name as web. So I'll go ahead and do it for this particular task. Okay, so here also our .NET application. This is for the .NET build. We did a Maven build on the agent. Maven was there inside the agent. We did a Maven build on the agent and then we containerized our application. In the second example, we are building inside a container and then we are going ahead and producing an image with the second build command. This one is actually building the image. And now we are actually pushing the image. This task is pushing the image. So there are two different variations. Maven build happened on the virtual machine, Microsoft hosted agent. .NET build happened inside a container. And image of that container is being picked up. One is multi-staged build, one is a single stage build. Now push is happening. Once this push has happened, we should be able to see our My Health web as well. Let's go and see. It says it is pushed. My Health web is also there. And two tagging I did. 904 is the build number. Latest is the tag. Both have same image, but I had tagged it twice. So here it had one single tag. I had not tagged it as latest. That's the reason you don't see that. Okay. So these are the two images. Let's look into the deployment pipeline. So there is someone raising the hand. Hey, Prashant, you have a question? Then do post it in the chat. So we have done the CI pipeline part. Now we have to do the CD pipeline part. We will go ahead and do the deployment of our resource. Things are all run. We will go and do the deployment of our resource. So let's go ahead and deploy. This is which application? Okay. This is my Health web application. I'll go to the release pipeline. I'll edit the release pipeline. This should fail already. A pipeline auto release has been there. That's the reason it has triggered. Let me stop this because this would fail because the web app name and all those things are not proper. I have not updated that. Let me go ahead and edit the pipeline and update the stuffs. So in the pipeline, you have variables, your ACR name, your database name, your password, your SQL admin user, your SQL server name. These things have to be updated. I can give the variables here, or I can also give the variables in libraries. There is a variable section there also you can give it. So ACR name needs to be updated. Let's go ahead and do that. Sorry, I was in the container registry. Where did I go? This I have to pick up. Database name. Database name was, when I created, let me pick from the command, it was not mhcdb. The variable which we had created, yes, this is the one, the correct one. Correct. I've picked up the correct stuff. Okay. No, the database name I've picked up wrong. This is the database name. Why I've picked up that? Sorry. The database name is my bad. The password. Password we had given in the command. So I'll go ahead and pick from there and give it over here. admin user was SQL admin only. Now I have to pick up the SQL server name. Server name is this. Yes. So I've given values for all the variables. These would be picked in this task. Let me show you the tasks. So here you are saying there are two tasks. One is DB deployment, one is web app deployment. Okay. So this is DB deployment. This is the web app deployment. In the DB deployment, you are going ahead and providing the name of the subscription. You would provide the name of your SQL server, in which SQL you want to supply, and the database name, the login, the password, all the variables which we have specified for the pipeline that would be picked and substituted here during the run. And what we are deploying the DACPAC file. Where is the DACPAC file present? The DACPAC file is present in this path. The path which was published by the build pipeline, that we are providing it over here. Now going to the web app deployment. So web app deployment has the subscription name, and we are saying it's Linux web app. Let's pick the proper web app name here. It is scoped to this RG group. Okay, let me go ahead and create in this as well the service connection. Azure Connect was the name of the service connection. So I'll go ahead and write that. I had to select service connection as Azure Connect. So let me pick Azure Connect over here. Yeah, now it gives me the correct RG name. It's fine. For this as well, I'll go ahead and pick Azure Connect. Then the app service will come in the dropdown. Perfect. And I'm saying image source is container registry. ACR name I have given in the variable section. This is the image which I want to deploy. And each time whenever a successful build happens, the build ID tag was there that we are going ahead and deploy. In case you want to always deploy the latest, you can write latest tag here. So this is just going to go ahead and deploy it. So I'll go ahead and create a release, which will go ahead and deploy our artifact. We can monitor this task. DB deployment will happen, and next our web app deployment will happen. If the deployment has happened properly, we would be able to access our application. So I'll give you my web app name so that you people can also browse my application. So once this application deploys, we are done with today's session. So by the time this deploys, if we have any questions, we can pick that up. All unnecessarily stuff, so I'm just going ahead. Good. We will wait on this page for the deployment to finish. And if we have any questions, we can start the Q&A session. The only last part pending is seeing the app is deployed. Hope you people are good. I know Rashmita had mentioned it's 120-minute session, but Mamta has already exceeded that. Sorry to everyone. Yeah, we would have to redeploy. So this is not a good DB deployment pipeline. I'm not sure what's your name, MR. So in case we have to do deployment of a database, then we have to have proper tasks for that. Here we have just tried to do the front end part. In the DB deployment, our intention was that we are just picking up the DACPAC file and we are placing it. That DACPAC file has to be recreated, right? So you can have a separate pipeline for it. What about others? Prashant, you have done the hand raise for long. You want to ask a question? You want to unmute yourself and ask a question? Or what is it? So, Rashmita, if we can allow mic for everyone so that people can ask question meantime when our last piece is happening. I have the option to allow it. Can I go ahead and do that? Vivek?
Yeah, I lost you
Yeah,
there
I
then.
lost you there then. No, no, I was saying I'm just allowing mic for all the attendees so
Yeah,
that they can ask
I'm doing
questions.
that. I'm doing that.
Okay.
Yeah, whenever.
Yeah, whenever. So guys, mics are enabled for you people in case you people want to ask any questions, please.
Yeah, you can go
You
back
can
and
go
forth.
back.
Yeah,
So
Mamta,
there
Mukesh here.
was,
So I have one
yeah,
question.
yeah, Mukesh. One
Yeah.
second. I'll
So
just answer the question which is there in the chat and I'll come to you. We have
okay.
built using Maven. What about simple Java application? So any type of build you want to do, you can do Maven build, Gradle build, any sort of build you want to do, you can go ahead and do that. Pump file, you specify the path and you have a respective tasks. So see what we do inside a container is just execute the Maven build command if we are doing in a container. So what you run on the virtual machine, same thing you run it here as well. It's nothing is going to change. Okay. So don't think we are running in a containerized environment, so things are going to change. It's not going to change. Command will not change. So how you build your application, run the same command, it will build it. Yeah, Mukesh. Sorry.
Yeah.
Tell me.
So so my question
So my
is,
question is,
we have the
we
Java
have the
application. So we build that on the uh, virtual machine, right? And in .NET we have
Correct.
built in the container. Means
Container.
why there the
Correct.
difference in both building one is the building in the container, another in the virtual machine.
It's not, there is a difference. It's two ways of doing it. I have shown both the ways. Um,
Okay, fine.
so
Okay. So
here,
means same thing we can do. Yeah, Java in the Java application we can build in the container as well, right?
so for that, I will have to have another Docker Compose file. Correct. In Docker Compose file, you will write how to build your Java application. How we had done .NET build with DLL and all that. Here you would say Maven build command inside the container. You can do it. I just showed two different flavors. Sometimes people build outside and just copy the executable inside the container and commit the container and create the image. Or sometimes people used two different files. They build in the container as well and they deploy in the container as well. So building in the container is a little bit easier. Why? Because um, I have taken a Microsoft hosted agent, if you people would have seen. So imagine this is the agent for the Java build in our case. I need to have Maven here. That's the requirement of my agent. Okay. And I did the Maven build on the machine and then created. So Docker was also there on this machine. Then only I could build an image, do a Docker build, Docker commit, Docker compose up. In case of web app, sorry, the .NET app, I did the .NET build inside this. So the dependencies which was needed was inside the container. I could create any type of dependent container with all the needed dependencies. I can pour inside it. Here, if too many things are needed for building, then I can't use a Microsoft hosted agent. Correct. So Microsoft hosted
Right.
agent has some limited capabilities. But here, my only requirement was give me an Ubuntu machine and whatever is needed, I will put myself inside the container and I'll build it. And second container, I'll actually build for the application container image. So I would say we would prefer this method. I would prefer this method over this method, but there are two different methods of doing it.
Yeah, yeah, got it. The second question is, there's a doc pack file. So what is that doc pack file? Means what it
Backpack file
contains?
is SQL database data is there in it. That only we go ahead and deploy in the SQL server. So we have not done any SQL database part and all that stuff, right? So a DACPAC file is a dump of your SQL, which you're going ahead and placing it.
Okay. Okay, means we already database and we are means a table and we are inserting the data into that table.
Yes.
Right? Yeah, okay.
Yeah.
Got it. Thanks. Yeah, that's
Yeah.
it from me.
Yeah. Thank you. So this is going to take some amount of time. Once it is done, people should be able to access my web app. I've given the link. Any other questions? All good? Did we like the session? Not like the session? Useful? Not useful?
Yep,
Yeah,
Mamta,
yeah,
Mahesh,
session is really very
one term.
useful.
Two people were speaking parallelly, so
Yeah, Mamta Mahesh here, one thought. So while opting the web app server, right? So we opted the Linux flavor, right? So
correct.
if I opt for the Windows one, the Docker file commands will vary. Am I right?
See, the Docker file commands would vary. End of the day, what sort of container you are creating, that varies. If you are creating a Windows container, then I would deploy it in a Windows type of environment. So what type of container I am creating? One is this Docker software, which is running on my host machine. This software has multiple flavors: Windows flavor, Linux flavor. Then a OS runs for this application. Container C1 is based on Linux OS or it is based on Windows OS. We picked up Linux web app because our containerized application was meant to run on Linux. In case you're creating Windows application, then certainly the base image, the from instruction which was there, right? That base image is going to change.
Okay, got it.
So this alone is going to change. Because my application is a Windows-based application. And normally, Windows-based application, we deploy in Windows machine only. So that the translation which happens from a Windows to a Linux call, we don't want to spend that much of bandwidth of resources utilization on that. So it's not that in a Windows machine, I can't run Linux containers, I can. But Windows servers we pick when we want to run Windows container. Linux server we pick when we want to run Linux containers. Because when I run Linux container on Windows, when the call comes, it's a Linux call. It has to translate to Windows call and then the response should go. So there is a lot of overhead here that we don't want to have. That's the reason we pick equal flavor, same flavor of it.
So it's a recommending option, right?
Yeah, it's a recommended option, correct.
Yep, got it.
Yeah, someone else was also asking the question. Running Windows container on Linux, not possible. You have to do a lot of circuits for doing that to attain that. So we don't do. End of the day, there is no advantage doing that. So prefer not to do it.
One more question. Okay.
Sorry, there is a lot of stat. No. Yeah.
Using code or the
What is?
yeah container, right? And there's a in Azure there's a using either using the code or the container in Azure Web App.
Sorry, I couldn't
Hello?
get your question. Yeah, code audit.
Yeah. In Azure Web, we can deploy our code using the Azure image, sorry, Azure container image or the code.
Correct.
Right. And and there's a one service also in the Azure container instance. So what is difference between the web app container and the Azure container instance?
So when I started my session, that time I mentioned that we can deploy in 3 different flavors. Correct? We can deploy it in Web App, we can deploy it in ACI, we can deploy in Azure Container Registry. So Web App is just for web applications. It's just for web applications with those supported framework like Python framework, Ruby framework, and only those versions. Like Python 3.6 is supported, 3.5 is not supported. If my application is based on Python 3.5, I can't use Web App. That framework is not there in Web App's backend. Azure Container Instance, I will pick up when I have any type of application. It could be a web application and a non-web application. This is also platform as a service offering. This is also platform as a service offering. Both are serverless. It's called as serverless because the servers are running in Azure. We are not aware of it. We just are bothered about our code. So you take your code, place here. In this case also, you take your code, place here. So if my application is a web application, but it is Python 3.5, I can't use web app. I'll go with this. If I have a group of containers, 2 containers are there, which I need to deploy. Like we had our web and DB, 2 containers were there in the Java case. If I want to containerize both and deploy, then I can use Azure Container Instance groups and I can deploy both in containers. At present, we have deployed web app and SQL, Azure SQL we have used. This is a other service altogether. In this, there is only one container, that is web application container. DB can't be containerized and deployed in web app. Only web application can be containerized, and that too only belonging to that specific framework. In ACI, any type of container you can create. You can create single container, you can create a bunch of containers. It's your wish. Then you would ask, why did I use? Did we understand the difference between web app and CI?
Yes. Got it. Okay.
In
Okay.
case
So,
of
and
Kubernetes, you take the responsibility of managing the workers' infrastructure. Not infrastructure, at least managing the worker. And when you have bunch of like 20 microservices are there, I would create 20 containers. Then tomorrow I'll have to scale. I need to orchestrate. High demand is there. You want to roll out, roll forward, a lot of other things you want to do. That time we go with management services like Kubernetes.
okay. Okay. Got it. Yeah. And also, one more question. Let's say I have a desktop application and I want to deploy it in as a container. So, can I in the Azure container instance?
You have a desktop application which you want to deploy it in a container, correct? That's your question.
Right.
Okay. So can you do it in web app you're asking, or what's your question? Is his voice breaking only for me or others as well? I lost him in between. What was the exact question?
Does as well.
It's
Okay.
breaking for us as
Yeah, Mukesh, if you can type your question, I'll answer your question. Meanwhile, I'll take AK's question. So for the deployment equal to which agent is used? Was it Microsoft hosted agent? So yes, in the pipeline, you can specify your agent. You can go with a self-hosted agent as well. In the pipeline, every time when you're building, you're specifying the agent. This is Microsoft hosted agent we have picked up. And even in the release pipeline, we have picked up the Microsoft hosted agent. We have picked up the Microsoft hosted agent.
AK here, but we can use either Microsoft or
Self-hosted.
Or Linux. I mean, in both choices are there, right?
Either Microsoft or what is your second choice?
Linux.
So see, Linux or Windows is not the choice. Choice is between Microsoft hosted agent or self-hosted agent. Microsoft hosted agents are on-demand picked up agent for smaller time frame till the pipeline is running. They will give you a server on demand with proper configuration. You execute your stuff. and after that, the server would be removed. It's released. And this server can be Windows server, this server can be Mac server, this one server can be a Linux server. Anything can be picked up. There are some set of operating systems with Microsoft hosted agents can provide. So from that choice, if you're picking up, yes, certainly you can do that. Or else your option is self-hosted agent. Like you have a server of your own. It could be running on Azure Cloud. It could be running on-prem. It could be your own personal laptop, anything. You configure it as per the requirement and you say this is an agent. So in the DevOps pipeline, under Microsoft Azure DevOps, you go and register this agent. And in the pipeline, I pick this agent in the dropdown. Suppose this is my agent 1. In the pipeline, instead of giving Azure pipeline, I'll say go and pick agent 1 and execute my pipeline in agent 1. So choice is between Microsoft or self-hosted. In both the cases, you can have Linux, Windows. It depends what type of build I'm doing. I wanted to do a Docker build. I picked up a Ubuntu-based operating system in that. Okay, does that answer your question?
Yeah, for the self-hosted agent, we had to take care. The
Hosted agent is our responsibility. We have to take care.
Yeah, got it. Thank you so much.
Mamta, we have discussed about 3 different types of containers, right? Like web app container, Azure Instance Container, and AIK, right? So, did you configure multiple web application in one web app container in a previous experience? So,
What is it? In case?
did we configure multiple web application in one container in Azure
No.
Web App?
No,
We
no,
can't,
no.
or we possible?
But why will you do that?
No, because so that Azure Web App have one container, right? Or is it can we deploy multiple web application in different ports, same like Azure App Service?
You can do that, but why will you do? We are going ahead and using web app and all those stuff so that we can segregate the things. See, if one application goes down and it impacts the other application, the entire stuff will go down, right? So why you want to deploy? Consider 2 smaller web apps and deploy them as individual instances. Why you want to club 2 things together?
So you were saying so create a different app services and do it.
Correct.
Okay. Okay.
I think we can take 1 or 2 questions at
Yeah.
max, and the recording will be available, and Mamta is available on LinkedIn and Twitter. So you can also reach out to Mamta or to myself as well, and we will be able to answer a couple of questions. If you still have some of those questions, and you after seeing the recording, you might pop up some of the questions, right? So do reach out to us. Um, we might take one last question if there is one.
This deployment is also going to take some amount of time, so I'll just leave it. Web app link is also there for you people. After 10-15 minutes, if you people are interested, you can go ahead and access the application. I'm giving my LinkedIn handle on the chat. In case you people are interested, you can connect. Thank you so much. Happy to know it's useful.
Can you also share that the web app link once?
DB deployment has failed. Let me see. Okay, the app name is not correct. It is unable to connect. So I think variable somewhere, it didn't write it properly. I have not changed the variable. So app service link I had given on the chat. I'll just do the deployment in a while. The variable names, I don't know why it didn't reflect, even though we had updated. We missed to save, I think. These are the old variable values. So I'll go ahead and quickly update it. Meantime, if we have any questions, last question we will pick up. And you should have this available. This didn't save. I don't know why it didn't save that time. I'll update this.
Yeah, Mamta, one more last question
Yep.
from my side. So in the Docker file, in the image, right, the image path, we have mentioned the ACR path, right? How the Docker file know that the credentials if it's not administrator?
We can also place our credentials in Key Vault and use Key Vault for accessing that. We could have done that as well.
Okay.
We could have done that as well.
Okay, so that means the Docker file have to find out from that credentials from the key vault or some secrets, right?
Correct.
Rashmita, you have the slide for check-in and
Yes,
surveilling as well.
Mamta
Yeah.
was sharing, so that's why I thought, you
You can take it forward. I'll just update the variable and rerun. People should be able to access those later as well. So I'll just execute it and leave it so that they would be able to access the application. You can unshare my screen, not a problem. Sorry.
Oh, sure.
So, Rashmita, this recording would be uploaded later on Microsoft Reactor YouTube channel, right?
Yes, it would be uploaded, but it would be uploaded by, say, Monday, Tuesday.
Oh, thank you.
Okay, please do the survey, take the survey link and do provide us the feedback and also do the check-in.
Yeah, please
And
do
also,
share your feedback with us.
yes, and by the way, today evening we also have a hiring meetup. So please join at 5.
Yes,
I think the Microsoft India global delivery team is going to be there, and they're going to talk about how they work with customers and other things, and also they're hiring. So they want to talk about their the roles which is there. So please do join in. Okay, thank you for joining in, and have a nice weekend as well.
Thank you, Mamta, so
Thank
much,
you.
and thank you all once again. Enjoy the rest of your day.
Thank
Thanks,
you.
Mamta. Thank you very much.
Bye, guys. Take care.